Hello guys, welcome to our class today, and we are going to look at preparation of salts, specifically preparation of insoluble salts. So we have a problem here that we need to solve, and it starts below is a brief outline of a method used in preparing lead chloride. That is the salts we are preparing. We are preparing lead chloride. So how is it done? Lead carbonate is added to warm dilute nitric 5 acid. So lead carbonate is added to warm dilute nitric 5 acid. So this is a reaction between a carbonate and an acid. And a carbonate, when you react a carbonate with an acid, the products formed are a salt, carbon 4 oxide, and water. Therefore, you're going to see effervescence. When the carbonate has reacted with the warm acid, more carbonate is added until the carbonate is in excess. So excess carbonate, the carbonate is used in excess to ensure all the acid has reacted, to ensure that all the acid that is present is used up. So after that, the mixture is filtered. Therefore, after you filter, you will obtain lead nitrate as the filtrate, of course, because when you react lead carbonate with dilute nitric 5 acid, is going to give you lead nitrate plus carbon 4 oxide plus water. The mixture is filtered, so the filtrate is lead nitrate. After filtering, some sodium chloride solution is added to the filtrate. The filtrate is lead nitrate in this case. Lead nitrate is the filtrate because when you react lead carbonate with dilute nitric 5 acid, the products formed is lead nitrate, carbon 4 oxide, and water. Some sodium chloride solution is added to the filtrate, which is lead nitrate. What will we see? Of course, is a white precipitate of lead chloride. So this is a step-to-step reaction to prepare lead chloride. So the questions come in. What observations are made when lead carbonate is added to warm dilute nitric 5 acid? What observation do you see? So what we see is there is production of bubbles, or there is effervescence. There is effervescence, production of bubbles. That's what we see, because when you react a carbonate with an acid, the products formed are the salt, carbon 4 oxide, and water. So the carbon 4 oxide present that is produced makes us to see the bubbles or effervescence. Explain why warm dilute nitric 5 acid is used. Why do we use warm dilute nitric 5 acid? Is to speed up the rate of reaction. To speed up the rate of reaction. For the reaction to take place very fast. Because when you increase temperature, in Form 4, we will see that when you increase temperature, you are going to increase the kinetic energy of particles, which is the carbonate and the acid, making them to collide more vigorously and frequently, hence a fruitful reaction. So the essence of us warming the dilute nitric 5 acid is to speed up or to increase the rate of reaction. That is why we use warm dilute nitric 5 acid. What happens when sodium chloride is added to the filtrate? I think this is the filtrate. To the filtrate, 1 mark. What happens when sodium chloride is added to the filtrate? What happens when sodium chloride is added to the filtrate? So, a white precipitate. Of course, it's the insoluble salt. A white precipitate is formed. Or somebody can say a white solid is formed. Next question. Write equation for the reaction between the carbonates and the acid. So the reaction between the carbonate and the acid, we are going to write it is lead carbonate is a solid plus nitric acid HNO3 is HNO3 aqueous. We are going to form a soluble salt, which is lead nitrate. We're going to form lead nitrate aqueous plus carbon dioxide CO2 gas plus water. So this is a reaction between the carbonate and the acid. So this is a carbonate and an acid giving us the salt, and this is what we filter to obtain as the filtrate. So this is our filtrate that when we filter after adding excess lead carbonate to dilute nitric 5 acid. Balancing the equation, we want to balance the equation. Nitrogen is 2 here. Nitrogen is 2, so we put a 2 here to balance the nitrogen. Oxygen will be 6 plus 3 is 9. Oxygen now becomes 6, 7, 8, 9. Hydrogen is 2, here is 2. Lead is 1, lead is 1. So the equation is balanced. This is the reaction between lead carbonate, or the carbonate here, which is lead carbonate, and dilute nitric 5 acid. So this is the reaction, and it is balanced. So after a reaction of the excess lead carbonate to dilute nitric 5 acid, we are going to filter to remove unreacted. If we, after the reaction has taken place, we filter to remove the unreacted lead carbonate. Will be our residue, and lead nitrate will be our filtrate. So let's continue to this side. It comes the filtrate and sodium chloride. The filtrate and sodium chloride. So filtrate was lead nitrate, and the sodium chloride that we added sodium chloride, so to precipitate out an insoluble salt of lead chloride. So the filtrate was here, the filtrate was lead nitrate, so it's lead nitrate aqueous plus sodium chloride aqueous. So this is, we mix two solutions of soluble salts to precipitate out lead chloride. So lead ions are going to take chloride ions, because lead chloride is an insoluble salt from sodium chloride, because they are aqueous solutions. So to give us lead chloride, a solid, this is now the precipitate, or the white solid, precipitate lead chloride plus, and sodium will take the nitrate ions, therefore giving us sodium nitrate aqueous. So these are ions that lead to formation of spectate ions. These are the ions that do not undergo change are known as spectate ions. So therefore spectate ions are sodium ions and nitrate ions. Ions that do not undergo change. They just see other ions changing state, but they do not undergo change. They are known as spectate ions. So spectate ions in this case is sodium ions and nitrate ions. So balancing this equation, I'm going to put a 2 here, because chlorine is 2, Cl is 2 here, and to balance it becomes 2 there, and here I put a 2 here, sodium becomes 2, oxygen is 6, and there is 6, it is balanced. So this equation is now fully balanced. That is the equation that takes place. So write the ionic equation for the reaction. An ionic equation is an equation that involves ions that undergo change. So ions that undergo change are lead, that form lead chloride. So it's lead ions from lead nitrate plus chloride ions from sodium chloride to give us lead chloride is a solid. So balancing this equation, you put a 2 there. So because chlorine is 2, charge is 2 negative, 2 positive, overall charge is 0, and here overall charge is 0. So even charge, you must balance charge. So this is the ionic equation. Name the reaction that takes place between the filtrate and sodium chloride. This is a precipitation reaction. reaction or double decomposition or double decomposition. This is the type of reaction in which solids are formed from aqueous solution. So this is an overview to show you how soluble salts can be prepared. For example, lead nitrate is prepared that way, reacting lead carbonate and dilute nitric 5 acid, and then we can form lead chloride by mixing lead nitrate and sodium chloride to precipitate out a lead chloride. That is an overview of how we prepare these salts. Thank you. Let's meet in our next class. Just look at the brief overview of the answer. Just take a look of the brief overview of what we have done today. So this is what we have done today. Thank you. Let's meet in our next class. Goodbye.